This setup contains a region where there is both an electric and magnetic field. That's the velocity selector on the left. What will happen is a particle will fly through the selector, and if it has the correct properties, it can get through without crashing into one of the plates. Only particles that have a particular velocity will be let through. If a particle makes it all the way through, it will form a cyclotron and eventually strike this detector a certain distance from where it entered. So why are only certain particles allowed through? Well, inside the velocity selector, there will be an electric force and a magnetic force. We'll assume that gravity is too small to even be significant here, so we'll treat it as negligible. Now, one of these forces on the particle is the electric force, and the other one is going to be a magnetic force, but I don't know which is which until I analyze the situation. So, we've got a particle of charge Q that is moving with velocity v through this velocity selector. We see that the field is directed downward, which means that the top plate must be a positively charged plate. The bottom plate is a negatively charged one. However, this does not alone allow us to know which force is the electric force, because right now we don't know what the charge on the particle is, and it wasn't given in the problem. They gave us the mass and the strength of the magnetic field, and even the strength of the electric field too. So let's assume that in the velocity selector, the strength of the electric force equals the strength of the magnetic force. Once the particle gets to the outside, though, now we can tell the direction of the magnetic force. It looks like the magnetic force is going to be pointing upward when the particle exits the velocity selector. So that right there tells us that this must be the magnetic force and the downward force is the electric force. With that in mind, positive charges are attracted to negatives, so this must actually be a positive charge. Now we can replace the electric force and the magnetic force with their formulas from the past. We'll get Q times E equals Q times V times B. It looks like our Q's are going to cancel here. So we'll get E equals V times B. And if we rearrange, we get V equals E over B. This represents the allowed velocities that will get through the detector. So let's just plug in. Our electric field was 3,000 volts per meter. Our magnetic field is 0.03 teslas. So it looks like only particles with a speed of 100,000 meters per second can actually make it through the velocity selector. Now we know the speed upon entering the region of magnetic field. We can finally find the radius of curvature with the formula mv over qb. The mass of our particle is 1.98 times 10 to the minus 26. We know its speed will have to be 100,000 meters per second. In the problem, it said that this was going to be a singly charged ion. So our Q will actually be 1.6 times 10 to the minus 19. And we'll put in our B field. We can now solve for the radius. It's 0.413 meters. So we can predict where the particle will strike. It'll be twice that radius.